Hi, my name is Anna Blumenthal, and this is my project 2 for ME3210, where I will be proposing a design improvement for insulating spray foam sealant. So, in this project, we were tasked with creating design improvements for a personal use product based on design factors in the format of design for X for ease of use, human factors, and ergonomics. So, the selected product that I chose for this project was insulating spray foam sealant, which I will be referring to as spray foam throughout the rest of this presentation. And as you can see, there are two main components: the can of spray foam and a nozzle that is attached by twisting the plastic piece over the can opening component until it clicks into place with this little extrusion right there, which then it can be used. So I picked this product because I used it a lot over fall break. I went on a service trip and was tasked with helping to insulate and seal the interior of a house that's being built. And so as you can see, the nozzle is attached to the can, and the can is then held upside down while spray foam is used. So here are images of this product being used by me. There were a couple major issues that we found with the design of the attaching mechanism between the can of spray foam and the nozzle, which created two major problems. The first one being that it was extremely difficult to twist the nozzle into the opening of the spray can, which in the picture on the right, you can see me and a friend of mine working together to apply a great deal of force onto the spray foam can, and so it took two people and a long time to make this happen. And the second issue is that even if we were able to successfully get the nozzle attached to the spray foam can, it would leak spray foam everywhere, sometimes while we were trying to attach the nozzle, but other times while the product was being used, so it didn't properly seal off the spray foam from getting everywhere. And so it ruined my gloves, and it got on people's clothing and skin, and was a design challenge. So the product improvement idea that I have proposed is to modify the nozzle attachment system to incorporate a hex nut to attach the nozzle to the can. And so this will be using an external piece to attach the nozzle and the can, which are both threaded, to one another, thus creating a better seal and just allowing for an installation process that doesn't involve applying a lot of force onto the can of spray foam. And so this design will allow for the nozzle to be installed and reinstalled on the spray foam can more easily and decrease the risk of spray foam from leaking during installation or use. And so this addresses mainly design for ease of use, but all three, as you will see later in this presentation. So the modified design on the left shows the can and the nozzle, which is similar to the previous images I was showing, but the zoomed in image shows that there's a hex nut now between the nozzle base and the can opening, and on the interior, both of those components are threaded and the hex nut is threaded. So here are the modified designs of the can opening and the base of the nozzle. And so the can opening is threaded on the bottom portion, as you can see right here, not the top portion, because the base of the nozzle fits over that, and so the threads line up, and it has a smaller diameter so that it can fit through the base of the nozzle, and so they are flush before the hex nut is even tightened over it to allow for that to be an easy process. And so these are the modified parts, and then the hex nut will be twisted and installed by hand on top of both of these components. So the hex nut is shown right here. As you can see, there are extruded threads on the inside of the hex nut, and it is tall enough to fully tighten over both the can opening component and the nozzle for the spray foam. The exploded view is shown right here, and so I want to point out the installation order. So first, the nozzle is placed on the top of the can where the smaller diameter is, and then the threads are lined up so that the nozzle can be placed. The ring up here ensures that the hex nut doesn't fall off of the nozzle from the backside, so just to prevent pieces from getting lost. And then the hex nut is tightened over both the nozzle and the can opening without applying a ton of force because the pieces are already lined up. You just use your hand and you twist the piece into place. And so this is a lot simpler, and I think it will just really make the process a lot easier and a lot less strenuous. Here is a drawing of the spray foam can assembly. And so the detailed view once again shows just the view of the nozzle, but also with the hex nut tightened over the can. And as you can see, it's not a huge, the design looks very similar, but I think that this will have a huge difference in just the impact it has on the product. So here are some advantages and disadvantages for this current design. So this design introduces the hex nut to attach the nozzle to the can, and so by doing this, it means that the user doesn't have to apply large force onto the can to attach the nozzle, which means that the seal, it decreases the chance of the seal popping or during installation, and that it reduces the risk of the seal popping or just spray foam leaking during use because a new piece is introduced, which means that it is better sealed than it would be without that. And so it's an extra safeguard. And so decreasing the likelihood that spray foam leaks potentially decreases the risk of skin exposure to spray foam. So these address both design for ergonomics by just being a less strenuous design for people to use and ease of use. And so a factor that improves design for human factors is that this product produces a lot less waste and is a lot cleaner than having a design where spray foam leaks. So it's more desirable for consumers. A couple disadvantages is that anything with threads can strip over time, especially when it's being twisted by hand, and so that is an inherent risk of the design. And this design doesn't account for the mechanism to unseal the spray foam can, and so having both the hex nut and lengthening the can opening component could influence the unsealing process. But because I was focusing on the attaching mechanism, I decided that this design was important. Here is the manufacturing process I wanted to focus on for this project was of the hex nut, and so this process includes wire drawing, which gets the product in the right dimensions, cold forming, which just cuts the wire into the hex nut and shapes it, thread tapping, which creates the threads, and heat treatment, which strengthens the material properties of the hex nut. Here are the material selections for my design. For the hex nut, I could have gone with stainless steel or carbon steel, but I chose stainless steel because of its strong, cost-effective, and versatile, and it's used in many applications. For the nozzle components, the manufacturing method is injection molding, and the materials used are PP because it's flexible, which helps with the unsealing process, and it's durable and chemical resistant, which is good when using spray foam. ABS could have also been used. Disclosure, this design was only made for educational purposes for ME3210, and I'm not affiliated with the brands I'm using. This project is to show how to improve a product, and no patent research or intensive filing patents will result from this design idea. Here are my works cited. Thank you for your time.